And before I go on, I should say that like this is totally a work in progress. Later on, you'll see that like we have not gotten very far in implementing this. So I am definitely all ears as to suggestions of like if you're using LibZFS, what do you like about it? What do you not like about it? Do these goals work for you? Is there something that we're missing here that should be a goal that isn't? Or are there things here that you don't really care about?
Do we have any idea of who's actively using LibZFS? Has there been made to collect that data?
Does anyone want to raise their hand?
Yeah.
You're programmatically using LibZFS?
Yeah.
Wow.
So a bunch of people. That's good. I thought that may be the case, and I'm glad that it is. But I would like to, those of you who raised your hands, if you could send me an email, or like one person from each team or whatever, send me an email and let me know like what you're doing, or if you like this or if you don't. I'll send out a message with a more formal proposal to the illumos discuss mailing list, probably later this month. So.
The reason I ask is I'm thinking as you're looking at the expressing this, I really like what you're saying. I hate carrying two versions of LibZFS, right? So it'd be nice to have an exit strategy for LibZFS 1, as you're calling it.
Yeah. So I have a little bit of notes on that later, but briefly, we don't. I don't think that we can. I don't. Well, let's just go to the next slide and I'll so I don't think that we should plan to completely replace libzfs 1, because there are some high-level operations that are part of libzfs 1 that are useful to programmatic consumers, like for example, ZFS, the implementation of ZFS send $R and the ZFS receive that corresponds to that, that are useful, very high-level operations, but fall far outside of the scope of the goals that we mentioned in terms of atomicity, simplicity. These routines, are implemented in terms of vastly complex logic to, for example, especially with ZFS receive from a recursive stream, to do the renames and destroys in the right order and figuring all that out. So that if we can do that, that would be great. But I don't think that should be part of at least the initial deliverables. So
given that goal, can we come up with a better way to distinguish these between the 1 and 2, like maybe LibZFS base or LibZFS 2?
Or LibZFS thin, I've got the same
low
and mid-level. I was just saying, you just can't do low-level and mid-level. That's the only thing that's...
naming, we can definitely have a fist fight via the email list later.
I'm just thinking that for the some guy who doesn't know anything about ZFS.
Well, some guy who doesn't know anything about ZFS should be reading the man page, which will only talk about LibZFS 2, right? There is no LibZFS 1 man page, intentionally, because it's not a supported interface. But LibZFS 2 being a supported interface, or LibZFS, whatever the heck we call it, will be a documented interface with a man page, and definitely, I'm open to ideas of better names. This is a working title.
Well, if we're not, I guess we're not documenting LibZFS 1 ever, right? And it's only there for the legacy guys, and I care less. But if the idea is that we're going to carry LibZFS 1 on indefinitely,
yeah. But let's table this for now, and we'll take it up offline.
Okay.
So these kind of complicated operations will probably still live in LibZFS 1, but they'll be implemented in terms of the base operations in LibZFS 2. So for example, probably send one snapshot, rename, destroy, and receive one snapshot will all be fundamental atomic operations in LibZFS 2. So the ZFS and ZQL binaries will probably link with both LibZFS 1 and LibZFS 2, but other consumers would be encouraged to transition completely to LibZFS 2. And obviously, that's kind of an implicit goal. So as we go about this development process, we'd like to hear from you if LibZFS 2 is not going in a direction that that would allow you to do that. So because of the simplistic goals for libZFS 2, some of the functionality is going to be pushed down in the kernel. So for example, some simple string parsing. So right now, libZFS 1 communicates about both property names and property value names in terms of enum values. So we're thinking to move some of this processing down in the kernel. So for example, the kernel, when you ask the kernel what's the value of the compression property, rather than telling you 3, it would tell you the LZJB, the actual name of that, that's being used in the CLI. And then other functionality would be pushed up to libZFS consumers. So this is mainly things that are better left to user interfaces. So for example, doing the LDAP lookups on names of users and translating that to numbers. And this is a little bit cut off, but translating sizes and bytes from the number to pretty printed 122 kilobytes. And this is a comma separated list, turn that into an NV list. So what have we got so far? Not too much, but here's 2 examples to kind of give some concreteness to the proposal. So the thing that kind of got me down this track was implementing ZFS multi-snap. So the idea is that for our programmatic use, we'd like to be able to create multiple snapshots all at one time atomically, which you can do with ZFS snapshot-r. But that takes snapshots of everything underneath one point. We only need to take snapshots of certain file systems there. So as a workaround, what we did is we just snapshot everything and then delete the snapshots that we don't need. Obviously, this is not the most elegant solution from either a performance or a failure modes point of view. So we wanted to be able to snapshot, take exactly the snapshots that the consumer wants. So in libZFS 2, we have added this new interface. So you specify the snapshots as an NV list. The keys in the NV list are the snapshots to be created, like that example. The properties are the properties to set on it. So for snapshots, there's a little known fact that you can actually set user properties on snapshots. So that allows you to set properties on them. And then now the results will actually return a list of errors. So you can find out, I tried to take these 7 snapshots, and these 2 of them had names that conflicted with currently existing snapshot names. And I've implemented this and also implemented the ZFS CLI interface, so that's actually a little bit richer as well now. And then this is another example of this is used to implement the space estimation when doing a destroy-v, where it tells you how much space would be reclaimed when I destroy this range of snapshots. So this is an example from snapshot A to snapshot B. There could be ones in the middle as well, and it'll destroy those and tell you how much space would be reclaimed. So interesting things to note about this are that we're specifying the data sets that we're operating on with the string names. Rather than in libZFS 1, what you do is you'd open a ZFS handle. You specify the string name to open a ZFS handle. That would give you back a ZFS handle T, which you could then use to do other operations like creating snapshots or getting properties or whatever. And what all of those routines basically did was get the name of the handle and then pass that down to the kernel. So you end up with this weird situation where I think it could be potentially very confusing to the consumer because they've opened this ZFS handle and like, okay, great. This thing definitely exists. This snapshot is totally there because I opened it. Now, oh wait, somebody deleted it. Okay, now I'm gonna pass it down to the kernel and or pass it to get some property about it, and then now that routine might fail with that thing doesn't exist anymore. So this, I think, simplifies the interface and also simplifies the understanding of the possible error modes. So here it's clear that you're just passing down the string. Obviously, maybe that thing doesn't exist. maybe it does exist, maybe it's read-only, maybe who knows what. So future work, there's a couple of more things that we want to do with this, besides just those 2 routines. So I mentioned that the iteration in the current LibZFS fetches 1 snapshot or 1 child file system per ioctl. So we'd like to change that to get many children with 1 ioctl, and then return to the caller an env list with all of the children. This will give us both improved performance, because we don't have to make many round trips to the kernel, and we might also combine this iteration with property retrieval. So you'd be able to get all the children and get some set of properties on each of them.
Right, and this will all be atomic, right? So you don't have stuff disappearing out from under you in the middle of iterating.
So that's a great question. That is still TBD. The issue there is that, so for those that didn't understand the question, with the current iteration, it works kind of like listing directory entries, where you're guaranteed that anything that exists over the whole time that you're doing the listing will be listed exactly once. But anything that's being renamed or created or destroyed while you're doing the iteration, all bets are off. So for example, if you have something that's being renamed, you could see it 0, 1, or 2 times in the iteration. This is true of like if you run ls. And also true if you do ZFS list. So with this, it allows us at least the potential to improve on that. The issue, there are some issues with the implementation because you could imagine if there are many, many children, then guaranteeing that you see everything exactly once it potentially involves like grabbing a giant lock to prevent anyone from doing any changes while you're doing this iteration. So this is still we need to evaluate the performance impact of that and see if there's any smart things that we can come up with to avoid that kind of problem.
So with this change, you don't need a handle at all?
Yeah, so far there's no need for any handles because we aren't caching any data. So let me get to the next slide about properties, and that ties in with this. So today, when you get properties about ZFS file systems with LibZFS, some types of properties are cached in the ZFS handle. So when you open the handle, it retrieves some set of properties, caches them in the handle, and then when you get a property from that handle, it just retrieves the cached value. So if it's changed since you opened it, you don't see the change.
So but of course you are caching at least one thing.
Pardon?
File descriptor.
Pardon?
You are caching at least one thing. File descriptor, an open file descriptor.
Yeah. So we have we are doing that. That's not a requirement of this implementation. You could open it every time, but for performance, yeah, we cache that. But there's no state there. That isn't cached state about the ZFS on this format. So as I mentioned, we cache some of those values, but then other properties, when you retrieve them, or we actually make a system call down to the kernel to retrieve just that property. So if you're getting, say, 10 properties, if you need to get 10 properties because you're implementing ZFS get or ZFS list, maybe 5 of those are cached, and then the other 5 are 5 more ioctls down to the kernel to retrieve each of them. With LibZFS 2, what we'd like to do is have, first of all, a single function to get any property type. So you don't have different functions for getting user properties versus regular properties versus user-used properties, etc. We'd like to have one call which allows you to get many properties. So you can do one trip to the kernel to get however many properties you need. So this is great, if you're implementing, say, ZFS list or ZFS get, you figure out what properties you're interested in, you send those down to the kernel, you get all those properties on that data set.